Hello friends, welcome to the VLSI design course. So in previous lecture we have covered the multiplexers and how to write a VHDL code for multiplexer, and we have simulated it, synthesized it, and we have generated a bit file. So similarly today we are going to write a VHDL code for a demultiplexer. So before that, just try to understand what is a demultiplexer. So the demultiplexer takes a single input and can be given to the n number of output, depends on the number of select line. So here the relation between the select line and the output number of output is number of outputs is equal to 2 to the power n. So this n represent the number of select line. So let us take an example. Suppose we have to design 1:4 demultiplexer. So number of outputs is equal to 4, 4 is equal to 2 to the power n, so n value becomes 2. So in this case our select line becomes 2. In this case select line becomes 2. Similarly, if it is a 1:8, then select line is equal to 3. If it is 1:16, then it is a select lines are is equal to 4. So let us focus on one of the example. Let us take one example, 1:4 Demux, and just look at its truth table. So being only one input, so here we are taking a D as a input, two select lines S0, S1 and 4 outputs, so Y0, Y1, Y2 and Y3. So as per the Demux operation, whenever the select line is 0, 0, or if it is 0 in decimal, the whatever the input is available on D, it is connected to the output Y0. Similarly, if input is select line is 0, 1, then whatever the input available on D, it will be connected to Y1, then Y2 and then Y3 subsequently. Okay. So like this we have to write a VHDL code for a demultiplexer. So to write a VHDL code for a demultiplexer, we are going to use our concurrent statement, conditional statement, as well as the selective conditional statement. So there are two statements, when else and the with select. But if you see here, the number of outputs are multiple, Y0, Y1, Y2 and Y3, but this conditional concurrent statement represent target as a only one output. Okay, so we'll see how to write a efficient executable VHDL code for the demultiplexer. So let's start with the ISE. So file, new project. So I'm giving name as a demultiplexer. Next, all these project settings like our FPGA family, device, package, everything is always same because we are using the same hardware platform. Okay, now add a new source, VHDL module, Demux 1:4. Okay, Demux 1:4. Now here, because of only one input, so we are taking D as a in, then select line. How many select lines? 2 select lines, so 1 down to 0, and we are taking here Y as a out, with how many output? 4 bits, so 3 down to 0, next, finish. So by default in VHDL, code is divided in 3 sections: library declaration, entity declaration and the architecture body. So let us start writing a VHDL code using now previous examples we have covered using the when else. So now we will try to explore about the with select statement. Okay, so let's begin with SCL select. Okay, now here output Y has a signal assignment. Now we have to assign, how we have to assign the, let's go back and see the truth table. This Y0, Y1, Y2, Y3, for this 4-bit output we have given a single name as a Y, and in that case when select line is 0, 0, the output should be 0, 0, 0, D. Let us see how to represent this in VHDL. So we have to write this 0, 0, 0 D. Am I correct? When select line is 0 0. Correct? Now here is some small syntax error is there. I will tell you later on. So let us write it. It's a simple syntax error, because as per the truth table, when select line is 0 0, we have to assign whatever the value of input D at the 0th position, it goes to the output Y. So let's finish it. 0 0 D0, as per the truth table I am just writing. We are going to correct this code. 0 1, then 1 0. In 1 0 case, this is 0, yes. In case of 1 1, D, okay. Or we can say here when others. So for remaining conditions, when others, every time in the with select we have to terminate with the when others clause. Okay, so as per the truth table, we have written like this: 0 0 D, 0 0 D 0, 0 D 0 0, and D 000. But this is not a correct syntax. Let's see what syntax error it will give. I will just compile it, save it. It will definitely throw an error, because the whatever the D we have used, it is not properly used, because it will not combine with the other input. So here type Y is incompatible with type of 000D, because D we have declared as a input single bit, and here other we have mentioned as a 3. So we have to 3 bits, so we have to separate it out. So there is a one, we can say operator in VHDL is called as the concatenation operator. So let's use it. So what I am doing, we are separating it, okay. So 3 bits, okay, initial 3 bit, and this D as a single bit. So this total width of the Y output becomes 4 bit. So let's separate it. This AND represent the concatenation operator in the VHDL. So it will combine the different input bits to match the total output width. Okay. So here and here, because of 2 bit, then here again this and. Okay, I think this is correct. Now just save it and now check for the syntax. I hope using this example we can understand one more operator uses, that is the concatenation operator. So this concatenation operator helps us to combine the different bit together, different bit width together. Okay, so like this, now our demultiplexer is ready. Let's synthesize it. Okay, now synthesis done. Let's see his RTL schematic. Okay, so input select line, input D, and output Y3 down to 0. So it is implemented using a shift register logic, or internally it is using the gates only. Okay, so once this synthesis done, let us once validate its simulation. So we'll do a simulation. So let's do it very quickly. So I am assigning D value, suppose constant logic 1. Okay, now if select line is 0 0, if select line is 0 0 and run for 1 microsecond, so whatever the value of D will pass to the Y0, whatever the value of D will passes to the Y0. Now I will change D value for constant, then select line, let us change it to 0 1. So whatever the value of D, it will pass to the 1. Let's run it. So here X value is going to y of 1. So whatever the value of d, it passes. Whatever the value of d, it passes. So let's take next assignment 1 0, and let's change d value to some other value. Let us take z. Okay, run it. So whatever the value of input is passes to the output. So that is the function of multiplexers and demultiplexers. So it is not necessary to have the input value of d in is always 0 or 1. Whatever value you are giving, it passes. So that's what it creates a lot of applications in the VLSI projects. So let's close it. So I hope simulation you people have understood. Now we're going to create a UCF file. We are going to create a UCF file. So just come back here. Now we wanted to implement the functionality of demultiplexer on this development board. Now for that we wanted to use switch as an input and the LEDs should be output. So being a demultiplexer, we have only one input, so this first switch we will consider as a input D. Two select lines will consider as a this bottom two switches will consider for the select line, select 0, select 1, and these four LEDs are nothing but my Y0, Y1, Y2 and Y3. Okay, so four LED outputs we are going to consider. Okay, so let us start the UCF creation. So simple method, right click, new source, implementation constant file, demux.ucf. So we are creating a UCF with the name Demux. Next it will create a UCF file and we can able to edit it. Okay, so automatically in our top model it shows here under the Demux. So let's start. So what are the signals I have to assign? So input D is to be connected to the FPGA pin location P31. So the syntax is net. Now signal D is connected to location P31. Okay, now this is over. Then select line, so SEL of 1. So select line we are going to connect this second last switch, so P24. Select lines MSB bit, so MSB bit is here, LSB bit is at the last switch. So P24 will be SEL1, P24 and P25 for the select bit 0. Okay, similarly now Y output. So we will start with the Y of 3. So MSB we are giving to this LED, first LED MSB output Y of 3, 141. Okay, so it should be connected to 141. Control C, Control V, Control V, Control V. So Y3 will just modify to Y2, Y1, Y0. So pin assignment is 143, 138 and 139. Okay, I think it's correct. 141, 143, 138 and 139. Okay, so just save it. Once it is save it, and then we are ready to generate a bit file. So let's generate a bit file. So parallelly it generates our synthesis report, map report, then translation report, place and route report. So all these reports are generated here step by step. Now with this place and route report generated, post place and route static timing report generated. So all these reports will understand step by step. Now this is very simple example, so there is no much information available in these reports. When you go for some complex examples like digital clock or we can say keyboard interface, so that time we'll just analyze these reports. So this our bit file is generated and is ready to implement on the FPGA development board. So the implementation we are going to see in our next lecture. So keep watching the videos. Thank you.